is a little bit different. I hope you will see the difference very soon. And is mainly designed for numerical computation. So let's see what is the content of this lecture. So I will start with the brief introduction, then we present the essential of the Matlab. Then we will go over the most basic stuff, how Matlab handles the algebra computation, how the matrix and vectors are defined, how to perform the computation on those types of objects. Then we will discuss the control flow, how to control the flow of your program, and at the end we show you how to plot some results. And the whole lecture is generally the introduction to the basics of the Matlab, the notation. Some stuff will be maybe new for you. Most probably will be known because Matlab is not very different from other languages, but we need to go through all those details to be at the same page during the laboratory. With respect to the laboratory, maybe we should start with the lab. Generally, I hope that you know the terms and conditions, how to get the credit. From my side, I can add that I will score you with the points. So you will get the points typically ranging from 0 to 10, depending on the complexity of the task, sometimes larger, maybe to 20. And you need to get 51% of those whole points to pass this Matlab part. Is that clear for you? And you will get those points at the very end of the lab. Sometimes depending on the complexity of the task and how it goes, sometimes I give you a possibility to finish the task at home and start evaluating the results on the beginning of the next lab. But let's assume that typically I will try to check your results at the end of the laboratory. It means also that some of you will have a little bit less time, right? Because this evaluation takes some time to go over all students in the class. So I will try to make it fair to that at one laboratory the person who had the less time, at the next it will have the longest time for preparing the results. And besides that, nothing more will change. In fact, we will also use a different tool, as you already know, right? This will be the Matlab, and Matlab is the proprietary software, so it means that you need to somehow get the license. And the information that I get from our university is that the students can have the access to the Matlab license. You need to register on the MathWorks web page using our university email. And with this email, you can download the Matlab and install on your PC, or you can have access to the online Matlab, which looks like this, right? So generally, it looks the same, right? The standalone application and this web-based application looks quite the same. I haven't used it before, this web one, so today we'll try to use the web one. on the daily basis, I typically use the standalone application. So it's up to you. I hope you will get this license without any issues. And I think you should do it as soon as possible and give the feedback if anything prevent you from getting this license. So I haven't asked how it was working on the previous labs. I'm not sure if you had the license for the Mathematica. Have you worked remotely on our lab, PC labs?
We used Wolfram Cloud.
Sorry, I haven't get this. So have you had that access to the laboratory PCs with the Mathematica, or you were work
No, we
remotely?
didn't.
You didn't. Okay, so let's see. I hope it will work for you. If not, we'll need to find the other method. We'll see. Let's assume right now that you have an access, and I will assume that you will have installed or you will have access to the web-based Matlab on the next lab, right? This is something that you must to have, right? Without that, it will be hard to get the credit. There are some other options, but let's start with this one. Okay. So before we start, any question from your side? Something that you would like to ask?
So I wanted to ask how we'll show our labs. Like it was with Mathematica, we will present the problem and then explain our solutions. Yes.
Yeah, generally quite the same. The tasks are on the web page, right? Description. And I will create probably the room for each of you, and we'll switch to the room, and you will share the screen and show me your results on your PC.
Okay, thanks.
Okay. Anything else? If not, I think we can start. You can send me an email anytime for the to standard email, first name dot last name and the address of the university. If you will have any problems, issues, please don't hesitate to send me the info. Generally, it's hard to find me at the campus right now, so this is the room I typically am in when I am on the university. This is the same room like for the Dr. Mushinsky, but probably it won't be the option in this semester. Okay, so let's start. I'm using the web page browser, the browser for viewing this document, so I don't have I need to scroll. And using this, because of this, I will try to switch and show in the MATLAB how it works. So let's start with the definition. I will read it because it's quite good description of what the MATLAB is. So the MATLAB combines a desktop environment tuned for iterative analysis and design process with a programming language. So two things that you need to be aware, that MATLAB combines desktop environment, so it's IDE, integrated development environment, kind of IDE. And also when you talk about MATLAB, MATLAB is also a programming language. So you need to say when you talk about MATLAB what you really mean, because sometimes you mean the programming language, and sometimes you talk about desktop environment, and also two different things, right? But we will talk about both. And this programming language express matrix and array mathematics directly, and this is what is the true power of MATLAB, right? That you can easily write the complex formulas using the standard, let's say, standard MATLAB notation. It's not so straight like in case of Mathematica. Mathematica almost give you the way for writing the mathematical formulas like they looks on your paper, right? Here you need to pay more attention, and it won't look so sophisticated. It's look more like writing the mathematical formulas in other programming languages like C++ or maybe Python, with the one advantage is that you don't need to create or implement new types for MATLAB for matrix and vectors operation. Here, the matrix and vectors are the first-class citizens in the language. So MATLAB give you a full integrated environment, and it's also the programming language. It's a scripting language, so you write the scripts. You don't need to compile them, right? It's nice that we can write complex formulas this way, but MATLAB implements something what we call JIT compiler. It's just-in-time compiler. It means that typically MATLAB doesn't run the scripts directly. It precompile them and run the precompiled executable, and all of those stuff are done are hidden from the user, and you don't need to do it by your own. It's done in the MATLAB kernel somewhere, right? This is how it works right now. In the past day and sometimes ago, MATLAB distinguished the script and precompiled. User was forced to precompile, but right now it's handled by MATLAB. So it means that it's quite effective when you compare to other scripting languages like Python. Probably MATLAB is much more performant in many mathematical operations than Python or other similar languages, script languages. MATLAB is also multi-platform, so it's run almost all modern platforms like Windows, Mac, Linux. I personally use Linux, but you also see that MATLABs run on the web page, so it also introduces another dimension in terms of the multi-platformness. It's last but not least is proprietary software and is extremely expensive, at least in terms of from our Poland perspective, it's quite expensive. There are some licenses for students. Probably they cost $50. I don't remember. Maybe it changed. So students have some possibilities to get the license, MATLAB license, but only for some subset of the toolbox that MATLAB provides. There are also some open source alternatives, and I will maybe talk about this later. I don't remember. Yeah, I have it. So we'll mention this later. Okay. And here is the web page of the company that who delivered the MATLAB. Okay, let's move forward. MATLAB has several advantages. The first is that it's really professionally built. It's rigorously tested and fully documented, and this is one of the strongest advantage of the MATLAB, the documentation. Really, you can learn MATLAB from documents, from the help that MATLAB provides. It's fully documented. I don't know any feature which is not documented. At least I'm not aware of such features. Maybe there is some newest, but the standard part of the MATLAB are very well documented with examples, with how-tos. You can go over the help, MATLAB help, and start from the beginning with the tutorials, learn about it. It's very, very good. I mean, in my opinion, it's the best place to get the information about the MATLAB, how to use it. And what you get is not the product you get is not something that is on the market for a very short time. It was there for a very long time, used in many different applications, and they guarantee the mm, that this high quality, right? This is very high quality product. The another advantage of MATLAB, it provides the iterative apps. So this is not only the IDE with and program language, but you also get some off-the-shelf application that you can just use in your system. Depending on the toolbox you have, there are many different applications for filter design, for generating the code for FPGAs, many different useful application that you comes together with MATLAB. MATLAB also has ability to scale. It means that can be run on your PC or very small device, but can be scaled to the cluster and can run the same code on the cluster or with slight modification. Generally, this is how we use MATLAB at our university. If you need the higher power resources, you can ask for the resources, run your stuff in the queue, put the task in the queue, and it will be run on the high performance computer that we have in the university. And you don't need to learn anything special. You just run this on the larger scale cluster. That's it. It also supports the GPUs and clouds. So this is something good to have. You can use also MATLAB to deploy the enterprise application. What it means that there is a way to extract a subset of the MATLAB features and deliver the application, which typically is a script of set of scripts, the code that you just produce with the part of the MATLAB, the core, and this is a standalone production ready application, right? You don't need to port your application to different languages. You can deliver the MATLAB code as an endpoint or as an end product, right? This is something that also good to have. It simplifies the development. Maybe it's not the cheapest solution, but it's doable. It's something you can consider. MATLAB can run on the embedded devices. This is somehow related to the scaling thing, but it can run in the sense that you can export the code, the MATLAB code, you can generate the C or C++ code and put on your embedded device. In this case, you don't need any MATLAB runtime. It's just the pure C++ or C code. Or even you can generate the HDL for the FPGAs, and you can put the already designed algorithm in the FPGA. And the last thing is that MATLAB integrates as I said, MATLAB is a scripting language. We will talk about this in a minute, but it also integrates the model-based design. This is a different way of different approach, different paradigm to develop the application. Instead of writing the code, commands, you use the blocks and design the diagrams, design the flow of the signals. So you code or you develop in the graphical way. You don't need to write any scripts, or you can, of course, but in the model-based design, you just draw the diagrams, and this is the diagram that you can run, simulate. You can do a lot of very powerful stuff with this approach, and this piece of the code is called Simlink. Okay, MATLAB can be used in many domains. I haven't listed all of them. Those are just general domains that MATLAB is useful and in which is used. So as you see, the list is quite long, and there are many different domains. I and Dr. Muszyński, we are roboticians, so we are interested with modeling and control system robotics, computer vision. Those are the things that we are interested in, but you can also use it for data analysis, for finance, risk management, right? For designing the electronic parts, simulate the electronic parts. In fact, you can do any, MATLAB can be used in any domain that needs kind of programming language with some additional math features. So it can, in fact, replace application written in any other programming language, in fact. Okay, so MATLAB is very strong tool, very powerful, well documented, but it's quite expensive, as I said. And there arise the question: are there any alternatives to MATLAB which can be used, let's say, for free? Like, and the question: there are some alternatives, right? Quite similar in terms of notation, or in terms of subset of capabilities that MATLAB have, but there is no one open source tool which deliver all those goodies that MATLAB has. There are no alternatives on the market right now, open source. So you will need to accept those limitations that those alternatives has, right? In fact, you don't need the whole features always, right? Sometimes you need only very small subset, and this is in this situation you can look for the alternatives. Okay, so the first most popular alternative is the Octave. This is open source clone of the MATLAB. It doesn't have so fancy front end, but it is a programming language, and it is also the integrated development environment. It has a very similar syntax like MATLAB, so you can almost reuse the same scripts from MATLAB in the Octave. There are some differences that you need to remember, but generally the syntax is very, very similar. The other one is CLab. This is the graphical tool which try to deliver this also the possibility of this model-based design, like Simlink. Also has its own syntax, quite different from MATLAB. Try to deliver similar basic functionalities, but generally you need to learn how to use it from scratch. My preferred alternative that I typically suggest as an alternative to MATLAB is the Python, plus a lot of extensions that come with Python. And in terms of mathematical stuff, the project is called SciPy, and it contains the extension for Python, which deliver a lot of MATLAB's functionality. What we don't have, in this case, we don't have this graphical model-based approach. But Python is very powerful language, as it's, and I strongly suggest to to learn Python along with Matlab. A lot of open source projects aimed for control, optimization, robotics, vision processing, AI, stuff like that are written in Python. So this is why I prefer Python. And the last one is the SageMath. It's also the Python-based environment which aggregates most of the Python-based projects which implement some kind of mathematical stuff. So we can say that this is like integrated Python plus SciPy plus a lot of other goodies that are on the market right now. It's very heavy. I mean, it's large, but it's integrated, so you don't have to look for those projects by your own. You get, let's say, off-the-shelf tool ready to use. So worth considering. Okay, so this is how the Matlab looks like. I should update this slide. This is one. Let's wait for. Okay, so we have the front end. This is how the Matlab looks like. We have a main window where we write our commands. There's a typical, let's say, bar, navigation bar, tools bar. Here you can navigate over the folders and your change directories. And here you will see this is the workspace, which lists the variables we create. Let's say if I create the variable, I will see this variable in my workspace. So you can rearrange this workspace. You can change the layout. I prefer to have a command only. But let's don't change this. I haven't used this this web-based tool yet, so I'm not sure how it will behave. So let's use this right now, this layout. It's up to you how you will organize your IDE. So you shouldn't expect any non-expected stuff when you have used the NID before, so most of the things are quite straightforward. So I wouldn't spend too much time of explaining how to create new file, open file, change directory. So it's not very useful, I think. So as I said, we have those main components. We have the command window where you can execute the commands, right? And this is the place which we call the sandbox. So you can go anywhere from here, right? You can do anything from this point. You can start writing your script. You can open the editor. You can run an application. It's up to you. You can compute some formula, whatever you like to compute, right? You can use the Matlab as a calculator. So this is the place you start playing with the Matlab, the command window. The workspace, as I said, it displays the defined variables. You can manage those variables. You can change the values, right? You can inspect them. Okay, yep. So I can. So as you see, it's a scalar, but we can create a matrix or vector maybe. So we'll have 1 by 2, right? Oops. No. Okay. So here you can edit graphically, right? But typically we don't do it this way, right? Okay. Then we have a current folder. This is the file explorer, let's say, what you need to be aware of that MATLAB, I mean, this current folder is quite important for you. So depending where you are on the drive, you can provide the path here, or you can select the folder manually in this window. You can navigate over your file structures. But the thing that you need to remember is that MATLAB assume that when you try to run any script, it looks for this script first in your local folder, I mean in the current folder, right? When you change the folder, MATLAB can probably will have a problem to find your script. So be sure that you are in the right folder before you will start executing something. Like, let's try to do something like okay, it should, yeah, I've created the folder, right? Let's enter to this folder. We'll create some, oops. Okay, like this. Yay, we have a file, cool. So let's do some fancy stuff like okay. Let's try to run this. This is ALA, right? As you see, it creates two variables. Oops, sorry, my fault. Okay, do it again. So it creates a variable A and B and compute C, right? And you see the results in the command window. But when I change the folder, I will go up one and I will be in the main folder and we try to use it again. Probably I will have a problem. Right now, it's not found, right? So this is common mistake that beginners have, that they change the folders, create the scripts in different folders, and try to execute the scripts from different places. So you need to remember about that. Okay. What else? We have this editor, right? This is what you have already seen. You can edit the script. This is standard editor with coloring the syntax. I mean, it looks much better on my desktop here. This web page based editor. I don't know why it doesn't coloring. Maybe I don't know. Generally, it's just standard editor. You can edit any file, any text file, not only the MATLAB related files here. You have a command history, probably somewhere here. Where is the command history? Probably layout. Oh, yes, pop up. Why not? Oh no, sorry. Docket. Yeah. So here you have all commands you have passed in the command window. Probably I can drag and drop them. At least I can do it in the standalone application. Probably it doesn't work in the web page based application. Generally, you can drag and drop in standard MATLAB, or you have also access to this history. When you use the arrow up and down, you can navigate over your history, or you can even filter it when you start typing with A and then you use arrow up or down. It select only the commands with start with this is right now it's A, right? And here I had only one, right? Like Allah. Okay. This is very nice feature of the MATLAB. The pop-up is also useful. Let's change this to pop-up. And probably when I start typing, yeah, the history, when I use arrow up or down, I have this pop-up window and I can navigate over my history, right? Okay, what else we have? And the help browser, as I said, the help is the one of the most powerful part of the Matlab. I have another slide about the help, so just show you how it looks like. I hope. Where's help here? Yeah, here one. Okay. So there is I don't know if you see the window. Hello.
Yes, we can.
Okay, so it means that's inside this window. Cool. So here is a full MATLAB documentation. Really, you can read about anything about MATLAB here. There are also command line help, but we'll go over this later. So let's avoid speeding this too much. Okay, so generally, as I said, MATLAB can be used in interactive mode using the command window. So this is interpreted environment like in Python. I don't know if you are familiar with Python. When you start the Python, you enter to the shell and you can execute any Python command in this shell. So the same is with the MATLAB. MATLAB can be, the command window is this kind of shell which you can do whatever you like, right? And the common or standard practice of using MATLAB in many scenarios is just to use it as a powerful calculator, but this is not the main way of using MATLAB. I want to only say that you can use MATLAB this way, right? Also, Python, you can also use it as a calculator. I don't know if you are aware, you can change the notation of the numbers easily, right? You can calculate some complex stuff in Python, the same like in MATLAB, right? You can consider it to use it as a more powerful calculator, but very expensive. Here we have some basic commands. You can check the what kind of variables you have in the workspace. Let's do it. So you can remove those variables. You can ask for help. Let's ask for help. What does it mean? Help. Who? Let's say, right? We'll get information about the command, and you can get this kind of information for any embedded command in MATLAB or function or any function that comes with toolbox. So you can also clear the command and quit, right? This is useful to know how to do this stuff when you run MATLAB without the window in the command window and you have only the shell without this integrated environment. This is also possible that you can work with MATLAB from command window, and then you need to know how to exit from the MATLAB, right? If you run something and you can write any program, right, here, and there will be the very long loop or infinite loop or something went wrong and you don't know what is happening, you can at any time hit Ctrl+C, and this will kill the execution of the current program. And I won't do it because probably this will kill my window, because this is not the MATLAB, it's browser, web browser. So not sure how it works in the web browser. I don't want to test it because Ctrl+C kills the application in Linux. So let's avoid doing this. But on your standalone application, you can kill this way the execution of your very long script. And yeah, the next thing is the help that I just mentioned. The help is very useful, and I think you should. This is the first place you should look for any help, for any information about the functions. What kind of what is the API, right? What the arguments means, what I should provide, what are the types that the function expect, what will be returned, and so on and so forth. So there are many, there are few ways of asking for help. First is just you know what the function name is, and you type like I did here, right? So you can read about this function, but you can also, let's say, help sinus, right? You can get any information about any function, any other function, or help plot. This probably will be a little bit more complex, yeah. And as you see here, there is also the a link to the documentation. So when you click it, you will be redirected to this, let's say, more in-depth help, and you can read about the specific of each command or function in this using this help browser with examples. As you see here, you can get a lot of useful information here, right? Okay. So if you don't know what the function name is or what you're looking for, you know only some piece, you can try to look for something, right? You don't know what. Okay, let's do it. Look for plot. And we'll get the list of different plots or functions that relates to the plotting, right? Maybe it wasn't the best choice because there are a lot of plotting functions in the Matlab, as you see. Okay, Control C, I don't want to use Control C here. So let's give it the time for it. And you can also direct call the help browser by calling doc, right? Like when you help prints the help in the command window, but you can call the doc, which open the help browser directly. Okay, so the next important thing that we should be aware of is that the types that Matlab supports, right? And Matlab natively supports the matrix, and everything for Matlab is a matrix in general, n-dimensional matrix, right? You can define any type, any dimension matrix, 1 by 1, or 2 by 2, and even n by n, right? When n is any number, integer number. So you can have, if you have such need, you can use multi-dimensional arrays, and it means that anything, also the scalar, are also treated as a matrix. So this means that no matter what you create, you can start using the standard function that are related to the arrays and matrix. And what you need to also be aware of, that the matrix are treated as a mathematical matrix, or sorry, the arrays are treated as a mathematical matrix, like in algebra, right? They are not the arrays that store some data, like you use standard vector in C++, or array, which is in fact only it's how you call it, it's a container for the data, but it doesn't mean that you can multiply two containers, right? It doesn't have sense. In Matlab, when you multiply two variables which are treated as a matrix, you expect that they will be multiplied like the matrix, right? Or you multiply matrix by vector, they will be multiplied like algebra says, right? according to the algebra rules. So having this in mind, anything you define in Matlab is a matrix. Okay, as you see, when I have defined that the variable a, which is a scalar, right? Here in the workspace browser, it's displayed as a matrix, which is size 1 by 1, right? But this is still a matrix. So any rules related to the matrix applies here. Okay, so what those matrix can hold, what kind of types they can hold, because matrix can also be treated as containers, right? So we can have typically we have double matrix of doubles, but we can have matrix of other types like cars, logic, booleans, and also different types of matrix. So we can store a boolean. We can have a numeric and floating point and integer values, right? We have single and double precision floating point, and double is a default. So whenever you type anything, like when I type a is equal 1, 1 is integer, right, in this case. But as you see, the class of this variable is double. I mean that this is 1 by 1 matrix that contains doubles. Even if I have typed only the integer, right? I can type 1b1. But d, let's say true, it will be logical, right? So we can also define the matrix that contains the integers, signed and unsigned, of any length. But this needs to be done in a special way. You need to somehow manually set what kind of type you want to assign, because the default is double, right? So when you want to use different type, you want to assign different type to the field of the matrix, then you need to do it in a little bit different way. You can also have arrays of cars, which typically, when this is the one-dimensional array, it means this is the vector, so it's treated like a string. So in Matlab, I can have like, and can take the first element. Oh, boom, boom. Sorry, not this one. This guy. And as you see, this is like a string, which the first element I can iterate over this array of cars and get each car from the array. And the newest Matlab distinguish the array of of cars and string. So there is probably since 2017, I don't remember exactly. Before that, there was only the vector of cars, which was the string. This is the way how you have defined the strings. But after that, they introduced additional type, which is the string, which allows you for storing the different coding for the string, not only using the ASCII characters. Okay, we can also store the function handle. So we can have a handle to the function. Do you know what is the function handle? Have you ever used function handles in C++ or C? This is like a pointer to the function. So instead of calling the function by name, you can assign the function address to the variable and then call this function by using this variable. So you can define this kind of stuff also in Matlab. And there is also something which we call the heterogeneous container. Generally, the arrays in MATLAB, they can store only the elements of the matrix needs to be the same type, right? When you define the matrix, let's say my A is right now, okay, maybe B. What is the B? B is double, right? So probably when I will try to assign, let's say, this still really works, but let's say assign what? This probably, yeah, this really works as well. Okay, what will be the other type? Not compatible, maybe string, or maybe the other matrix, right? So I can't have element of the matrix which is another matrix or vector, right? So I mean, this is possible, but generally this in this case, if I have defined my matrix as a matrix of doubles, I can't assign different type to one or only one of the fields. So this is that you need to remember. But if you have a need for storing different elements in different places in your array, there is something that we call the cell, and this is the type of matrix, cell matrix. Let's call it the how it was used. Let's say we can have yep.
I'm sorry, but could you make the zoom in the web page because it's hard to see, kind of, because it's so small. I think Control Shift Plus or something should work.
Okay.
Oh, great, great. Thank you. This is perfect.
So, okay. So as you see, I created the variable d, which is a cell. This is, we use this type of notation for defining the cell arrays. And first element of this cell contains the 1 by 2 vector, and second one is just the string, right? This is not possible in normal matrices. And MATLAB also defines something what we call the struct. It's dynamically defined struct. Like I can have, let's call the E. Okay. Okay, and then, oops, sorry, E is my struct that has 2 elements, and I can use it like in normal struct. E ola, which is a vector. It took ages to execute in the standalone application. It's intermediate. I mean, you get the results at the same time, right? This lag is because of the web-based application. It is typically is not so, doesn't take so long. Okay, so this is more or less the types that MATLAB operates on. You will learn more about that maybe in the future, but for now it's enough to start playing with the MATLAB. The next very important thing that you need to know about MATLAB, that MATLAB is about the language. Right now we are talking about the language. So we create the variables by assignment, right? You have already seen it, that when you want to create the variable, you don't need to define it before, like in C or C++, right? You can dynamically type to create a variable. So anytime you assign something, MATLAB creates the variable. The other thing that you need to know is that the variable type is dynamically typing, or the language is dynamically typing. So what does it mean? That F right now is 1 by 1 matrix of double, right? But right now I can assign different type, and it will be the type of the variable will be changed, right? So right now f is the logical 1x1 matrix, right? So you can change the type of the variable by assignment. So in this sense, is dynamically typing. But if I have, let's say my a is what? A is string, right? Okay, let's wait a little bit. Oops. Probably it's due to the lag, yeah. So if I have, I want to access one element of this, right? I can get it as A, but I can't assign here a different type. Probably like I can't assign the vector here, right? This is not possible. So it's dynamically typed language, so you can change the type of the whole variable, but you can't type only one element of the variable if this is a matrix, but everything is a matrix in Matlab. So this is the thing you need to remember. You don't need to declare, right? You need to pre-declare the variables. But for some reason, sometimes it's good to pre-declare them, especially when you create the large matrix or variables or vectors. The problem is that anytime you change the size of the matrix, like A is right now what? It's 1/3, right? So I can add another, I can extend the size, like 1/4, say it will be ABC, let's say D, right? So right now it's a string of D, and anytime you change the size, it's time consuming. Matlab needs to reallocate memory, needs to run some stuff in the background. So when it's better from the performance perspective to first, let's say, create the matrix like 1/4, right? And then, oops, what? Zeros, zeros. Yep, and then change the values of those elements, especially if this is the large matrix. So in these cases, it's better to pre-allocate for speed. And the names of the variables are quite the same like in other languages. So the rules are quite similar. The variables need to start with the letters, followed by letters, digits, and underscores without any white spaces. Can contain up to 63 characters. It depends on the configuration. The typical is 63, but it can be changed. The variables names are case sensitive, so you can use the different cases for distinguish the variables. And you can't use any reserved words or built-in function variables, so you should avoid it. Matlab defines some special variables that are always defined. ANS, this is the last result of the last executed function. So when you do not do any assignment, like here I did assignment, so I assigned I mean 0 vector to the A, but if I will call 0 only without assignment, can I do it? No. Let's do it. Okay. Zeros, sorry. Zeros. So Matlab automatically create this ANS variable which contains the result. Sometimes you can use it to create the chain of commands, right? To reuse the result from the previous command as an input to another command. but this is not the best way of writing the scripts, but you can do it. EPS is accuracy of the floating point precision. I hope you know what it means, that we are running the double precision numbers, and this is the precision of our machine. So probably on yours it will be quite the same. So you shouldn't expect to have precision lower than this, right? Um, we have also imaginary units. You can use I and J. The thing is that those two letters are very popular when you write the for loops, right? We would like to, it's often in C or C++. We have for I is equal something uses as an iterator, right, in the for loop, and you can do it the same in Matlab because you can redefine those variables. So I is defined right now. This is imaginary, right? Variable, but I can write I is equal 1, and right now I is not longer the imaginary. But you can use, if you redefine I, you can't use it to notate the imaginary part in the complex numbers. But if you need to do it again, you can redefine this again, and it will be the imaginary again. So we have also pi, some inv, none, some limits. So you need to be aware that those type of variables are there. Sometimes they are useful. So I just mentioned that those types are there. Those types of variables are there. Okay, let's move forward. So we know how to define the variables, what kind of types we have, how to create them. Then the question is how to write the expression. And expression is any legal combination of the numerical values, mathematical operators, variables, and function calls, right? What does it mean? It means that you can write very long chain of function calls with have other fun one, right, which is valid, whatever here we put. So it can be any complex combination of such stuff, right? So you can write very long expressions, and this will be treated as an expression. If you have very long statement and you want to wrap the line, you can use 3 periods. Let me show you. Let's say this is very long line, and I would like to continue in next line. So does it work? I don't know. A, maybe, probably not, because there are totally different types. A is vector, B is, I can't add it, but probably I can add A to B. Sorry, A plus C. Yep, yeah, okay. So this is how you can do it. Semicolon is have different meaning. For now, you need to know that it indicates end of the statement. So what does it mean? That you can have you can write several things in one line. So if you want to mark the end of each statement, you use semicolon for this. The semicolon can be also used for suppressing the output. As you see, the A, we see only the B, right? But why we don't see that A is equal, right? And so so if you want to suppress the output, like let's say right now we see the output, right? But using semicolon, we just evaluate the C, but we don't see the output. And this is especially useful when you write the scripts. I don't want to see the output of each intermediate result, right? Sometimes I would like to see, then I remove the semicolon, but in the most cases, I just don't want to see the results, intermediate results, and just needs to have the value somewhere stored in the variable. So this is how we use this. Then we have a comments, which we comment with the percent sign. So you can put the comment at any place, and everything later will be treated as a comment. So this is not interpreted by the MATLAB anyhow. Okay, let's wait a while. This is probably due to this lag. I mean the network. Generally, it's done immediately on the local machine. Okay, maybe. Oh, maybe I can't evaluate it. Maybe a equal 1. Yep, this works. Okay, cool. What else? We have also block comments with curly brackets. So if you want to write some more comments and you don't want to do it comment line by line, you can do it with the block. And the last thing is the format command, which changed the way how the numbers are displayed. Let's say we will have 1 a is equal 1 times 3. So you can format how this how the floating point number is displayed, how many numbers after the dot is displayed, and what if you use the mathematical notation, scientific notation, or this standard notation. So you can change this with the format command. Okay, the last thing, next thing is the operators. They are quite the same like in other programming language, so I don't want to get into details with few exceptions. I will only mark the exceptions that you need to be aware of. Okay, first, as I said, any mathematical operator applied to the variable, which is a matrix, use algebra rules, right? So when you add to matrix, they need to have the same dimensions, right? Or you can add scalar to the matrix. When you multiply matrix by matrix or matrix by vector, the dimensions needs to match, right? Match. So this is the first thing. Matlab support also the operation on the elements of the matrix. So sometimes you want to multiply, let's say, two matrix, not like the matrices, but each element of the matrix by element of other matrix, right? Let's say we have, let's describe this. Give me a sec, I will annotate. So let's say we have two matrix A, B, C, D, right? E, F, G, H. So normal multiplication is A times E, B, G, right? This is how you multiply the matrices. But sometimes you want to have A, E, B, F, C, G, D, H, right? To have this kind of multiplication, you need to use a dot before the operator, and it means that this operator will be applied in the element-wise fashion. Instead of multiplying the matrices, you will multiply each element by each element of the matrix. The same is with other operation. The nice thing is, I mean, the something that is quite different from the standard languages is how you divide, because we have a matrix. So when we have two matrices, we can divide. We have the left and right division, right? It means it means from which side you will multiply by the inverse. So this is the right division and this is the left division. And this is important when you start playing with the matrix, right? Because this makes the difference. And the hat sign is also interpreted in different way in the Matlab. So when you write a times hat 2, it means power of 2. But what is the meaning of this sign in C or C++? Who knows?
XOR.
XOR, exactly. Exclusive OR. So this is something different, right? You need to remember that this is not XOR. It's more natural way, right? This is the notation is quite straightforward for me from the mathematical perspective, but someone who plays only with the programming languages, this is something different that you need to remember, right? It's not XOR anymore. Okay, and the last thing is the transpose. So when you want to transpose the matrix, this is how we're doing. Generally, this is is in fact the complex conjunctive transpose. It means that it applies the transpose also for complex numbers. So the standard transpose that which is let's say element-wise transpose. This is the method for transposing this kind of matrix. Generally, as long as you don't use any complex number, or you are sure that this complex number won't appear somewhere in the middle, this is how we transpose. I mean, mostly in most algorithms I implemented, this is how I have transposed the matrix. But you need to remember that this transpose is for complex numbers. If the numbers are not complex, the transpose is just the same like this one, right? Okay. What else we have? We have the relation operators, which are quite the same. This is maybe different, right? Because in C we have exclamation mark, right? This is how we write this. Maybe side note is that, as you see on the right side, we have those commands, and you can do the same with the function. This is the function you can call equal something, right? With two arguments. You can call a function instead of writing the symbols. Sometimes it's useful. What else we have? We have the logical operators, which are quite the same. What was the short circuiting? I don't remember. It was important. Let me check. What it was. Oh, I remember. Okay. Short circuiting means that the second operator is evaluated only when the first one doesn't meet I mean, doesn't resolve the result, right? So sometimes after evaluation of the first element, you know that the result always will be have some value, right? In this case, you don't evaluate the second one. This is the same in C and C++. So MATLAB also don't evaluate this when this have a meaning. I mean, this is feature that you need to be aware of, right? When you write the script. Generally, MATLAB follow the C rules, so you are quite safe. But if won't, in some cases, if you have, let's say run and do some function, right? You assume that if run is, let's say, false, you don't run function. But if this function do something, I don't know, control some mechanism, I don't know, robotic arm, right? And you don't have this short circuiting, then this function will be evaluated even if the run is false, and this may result in some unpredicted motion, right? This is only the example, but very important sometimes. Okay, what we have next? We have also the special characters. We have add symbol, which define the function handle. This is how you assign the function to the. Let's try it. Maybe can I do it? Let's try to use it to. Let's say that a is a function of what? How to use it? I don't remember the syntax. X is in x plus y, maybe y, something like that. Yep, and then by calling 2 or maybe p2. Okay. Plus 2 is equal to 3. Okay, this is how it works. So right now a is a function, right? This is variable, right? Which we assign the function. This is the function with 2 arguments, and this is what this function do. So I can call this function like be a function and provide 2 arguments, and this function will be evaluated. Is this clear, more or less? Sometimes useful. Okay. Where I can remove this annotation, clear. Okay. Okay, let's move forward. Then we have this period or dot. So this is decimal point in notation, in numbers notation, right? It can be element-wise operation when we put the dot before the operator, like dot multiply, dot divide, dot sum, and so on and so forth. Structure field access. This was also shown when I have a structure. Oops, where's my? When I have a structure. Do I have any structure here? I have E, right? E is a structure which contains 2 elements. I use dot to access the element of the structure. Or this is the object property of or method specifier. In MATLAB also allows you for using the object-oriented approach. We won't discuss this during this lecture, but you use the same notation like in case of C++ to access the objects method or properties. This else is 3 dots. This is line continuation. Comma, this is the separator, standard separator like in other languages. Colon, this is we'll discuss how to use colon. This is the vector creation, so you can create the vector like A is equal vector from 1 to 10, right? And it create me equally spaced vector with 10 elements. Colon is used for indexing, so I can, let's say, if I have matrix 1, 2, 3, 4, this is my matrix, right? And want to, let's say, get the first column of the matrix, so it will be take all rows, right? First column. Oops, no, why? Oh, okay, got it. Sorry, this is not, this is how we do it. So we took the first column of the, it means that take all rows. If I put this here, I will take first row, it means take all columns. So it take me this guy. Okay. Then we have also for loop indexing. So you use this this column in the sense like you define the vector to specify the range of the iteration. So this is a different use case. Okay, so we have colon. We will discuss this later, or how to use this colon, because this is quite powerful notation, quite different. I mean, this is not typical, usual for other languages, so it's quite different for Matlab, or specific for Matlab. We have a semicolon. This is signify end of the row. So you mark the end of the statement or the end of the row. We were using this in somewhere here to run two commands in the one line. But as you see here, when I have defined the matrix, I was using this for distinguishing the rows. This is the first row, semicolon, the second row. Okay. Then we have parentheses, which is used for operator precedence. So what does it mean? That means that you group the operation, right? When you want to add, this is standard command. It's like 1, 2 times 3. It means that first we do 1 plus 2, and then we multiply, right? This is the meaning. Function, argument, and closure. It means that if we have our function, right, like this, so we call this function. Oh, sorry, it's not a function anymore. Oops, it was like here, right? We had the function. Where is the function? Here, right? So we use as a function arguments, right? We mark the function and arguments. So this is the second meaning of the parentheses. And the last one is indexing. This is how we also access to the variables. So if A is a matrix, right? 2 by 2 matrix. So to get element of this matrix, let's say the first element in the first row, we can have a second element in the first row, first element in the second row, and so on and so forth, right? This is how we access, and this is the place where we can. It's hard to distinguish if we call the function or if we access the element of the matrix, right? Because as you said sees before, A can be a function, right? And calling the function like here is quite the same like accessing the element of the matrix, right? If you don't know what it is, if A is a function or A is a matrix, it's very hard to say what you are doing here, only looking at the code, right? So this is, let's say, one of the drawback maybe of the Matlab. Square brackets, so you use this to construct the array. You can also cancel the array. Let's show this. So I was using this notation here, right, to define vector or matrix. But you can also, let's say, remove the second column. So I will say that a second column. So I need to have all rows, and second column is equal to empty vector, and this is how you remove the, so A contains only the first column right now, right? This is how you can remove something from the matrix or from the vector. It also, of course, define the empty matrix or empty vector. I can define A is just empty, right? And what else? I can multiply output arguments, multiple output arguments assignment. Yes, this is the also one of the nice feature of the Matlab, that function can return more than one return value. In C or C++, you generally return one value. You can, if you want to return more values, you need to define a kind of struct, or use in C++ 17 you have this, you can return the tuple. In Matlab, you can return the vector or struct or whatever, which contains several elements. And this is how you assign, let's say you have a function. In fact, when you define the function, you say what this function returns, right? So here you have args, input args, and here you have a list of output args, and this will be returned as an output. So when you want to call this function, right, you need to somehow say, okay, let's assign the first return as a, then second as a b, then you call the function, let's say fun, something here, right? This is how you call and how you distinguish what will be stored in which variable. So this is the way how we use these brackets. And curly brackets are used for cell array assignment and getting to the content. So the cell array, this is the array that can contain different types of I mean, each field can be different type. So like this, oops, sorry. It can be a vector, and okay, so this will be my cell array. And to get the first element of the cell array, I use it as an index, right? And I get my vector. If I take the second one, it will be the string. Okay, I think this is the place we can stop for today. Okay, what do we have? Okay, let's finish this. Character, special characters, and this will be the end. We have 1 minute. So we have a %, which is a comment or conversion specifier. This is used for printing, right? Like in print, standard C++, sorry, C print uses for converting the conversion specifier. This is how we use, how we make the block comments. Exclamation point, this is used for operating the, if you want to call the system command. ls, this is the command in Linux to list the content of the folder. Of course, Matlab has built ls. I was using this touch, right? Touch command, right? This is not the, this command is not built in Matlab but I can execute it, and I will create on the file system the file Ola. You see, this is new file here. So this is how you can execute system command inside the Matlab environment. Okay. What are single quotes? This is the how we define the character array. In fact, this is the string. Double quotes, this is the string constructor that I mentioned. Yeah, it's since 2017. Space character is separator. Tilde is logical node, so you can negate this way the value of any argument. Let's try it. Node 1. Okay, node 10. It's still node 0, 1. So it works as you see. And equal is this is assignment. That's it. Any questions?
Sorry, I have a question about what is let me see versors in laboratory task.
What is the versor?
Yes, I don't
Uh,
get.
I mean, versor is a standard algebra object, which is a unit vector,
Oh, unit vector. Okay.
but in the direction of the axis, like
Oh, yeah.
this is the
Okay.
versor.
Thanks.
Anything else? Okay, so that's it. Thank you very much for today, and we will see on Friday on the lab. Bye.
Thank you. Goodbye.
Goodbye.
Goodbye.